So you cannot cancel the signs, but we can give that sign, the denominator belongs to both the sine of x and the 1. Let's try that. So if we have sine of x over sine of x plus 1 over sine of x. Does everybody see what I did?
Yes.
What is sine of x over sine of x?
1.
What is 1 over sine of x?
1.
No, it is not.
What, not?
But thanks.
Cosecant.
It's good.
Oh, yeah, that's right.
We're there. Done. I don't see anything I really can do. You look at your Pythagorean rules and see if there's anything that'll convert to like a 1 or something, because that's easy. But I don't think that's the case, right?
Right. We just
So-
use the cosines.
So we just have to do cosine squared. One of the things I noticed when I was correcting your papers, number 1, they're not neat enough for me to see your logic. Number 2, if it starts as a square, like cotangent squared, you have to simplify it as cosine squared of x over sine squared. You're dropping squares, or you're adding squares where they don't belong, and then you don't know what to do with them because it's wrong. So whenever you leave one section, do a little check and make sure that everything you've said is true, because we're having trouble with that. And then cosecant is 1 over sine squared of x minus 1 over cosine squared of x. All right, so we need a common denominator on the left and the right. So over here we need to add a cosine. I'm going to change colors so we can see what we added, and we add a cosine. And here we need to add a sine. And here we have a sine, right?
Wait, is this coming from the other side of the...
I'm finding a common denominator for that left side of the equal sign. On the right side of the equal sign, I'm going to put a cosine and a cosine squared and a sine squared and a sine squared. All right, so now on the left side, I have cosine to the 4th minus sine to the 4th over cosine squared, sine squared, equals cosine squared minus sine squared over cosine squared, sine squared. So really we have the bottoms equal to each other, so we're good there. We just need to make the tops equal to each other, right? All right, so I've got sine and cosine to the 4th on the left side. I'm going to leave the right side alone and assume I can make the left side look like the right side at this point, okay? Cosine squared minus sine squared is nothing, but cosine squared plus sine squared is, right? So we can't do really anything on the right now, so let's leave it alone. Sometimes it's okay to leave one side alone and try to figure out the left side. All right, so on the left side, that is difference of two squares. And it's cosine squared minus sine squared and cosine squared plus sine squared. It's the same rules you learned in Algebra 2, but kind of on steroids, right?
How do you know to do that?
Because I'm stumped. I've got to make the left side look like the right side. Well, let me see if I can factor it. Factoring is one of the things you have to look for. And this one is a difference of two squares, so it works out. Well, look at this. What is cosine squared plus sine squared? 1, so he really goes away. And this is equal to cosine squared minus sine squared over cosine squared times sine squared of x. Does that look familiar?
Yeah.
We're there.
What number is this?
I think 20, because I said the last 5 were hard, so they picked the last one thinking it would be the hardest, but I'm not sure if it is. I don't know. All right, so secant squared of x plus cosecant squared of x. Is that one of your Pythagorean triples? Those Pythagorean ones? I don't think it is. So let's go ahead. And leave the right side alone, which is typically what you're supposed to do. You're supposed to make one side look like the other and do all the changes to one side. My rule is just don't go and put anything from the right to the left or the left to the right, but you can work on both sides if you need to see it, okay? So I don't really care. But let's leave the right side alone for now and see if we can make it work. So we've got secant squared of x is the same as 1 over cosine squared of x. And cosecant squared of x is 1 over sine squared of x. Got it? Well, what do we have now? We have two fractions. What do we need in order to add fractions?
Common denominator.
common denominator. So we're going to add a sine squared of x and a sine squared of x here, and a cosine squared of x and a cosine squared of x here. This is getting very simplified. So now I have upstairs sine squared of x plus cosine squared of x, and downstairs I have sine squared of x times cosine squared of x. Got it? So the top is the famous identity, and it's equal to 1. And so we have sine squared of x, cosine squared of x. Got it? Well, I have a cosine up here in the basement, so let's leave him where he is, because he's where he needs to be. How do I bring a sine squared upstairs?
Do it on the bottom and the top.
No. What do? You only do that if there's an equal sign. What do? What is 1 over sine squared equal to?
It's cosecant or cosine.
Cosecant squared over cosine squared. Does that look familiar?
Yeah, kind of looks like the other side.
When you see a fraction, it's really easier not to look at both the numerator and the denominator, but look at the, one at a time. So I'm going to put that 1 up there and ignore him for a while and work on the bottom first. The bottom is sine squared over cosine squared times sine squared, right? So when I simplify that, I have 1 over sine to the 4th over cosine squared of x. Now, when we're looking at this, 1 divided by a fraction is 1 times the reciprocal of that fraction. Okay? So that's kind of the left side. Really nothing I can do there unless I say, oh, but I need to make it look like this over here. So what is cotangent in terms of sine and cosine? It's cosine squared over sine squared, right? So I used one of those sine squares, and times 1 over sine squared, I use the other sine squared. You see how I separated those two? What is cosine squared over sine squared? Cotangent squared. And what is 1 over sine squared? We're done.